In the beginning, we thought it was empty. We drew the edge of our neighborhood at Neptune, then at Pluto, then at the heliopause, where the solar wind finally surrenders to the interstellar medium. We sent Voyager 1 past that boundary in 2012. We sent Voyager 2 3 years later. We told ourselves that beyond that line, there was only the scattered debris of creation, ice, dust, and the occasional wandering comet, frozen in a half-sleep that would last until the end of time. We were wrong. The Oort Cloud was supposed to be a graveyard. Instead, it may be a warning, because the more we look, the more we realize. It is not empty, and whatever is hiding inside it is massive. To understand why this matters, you have to understand what we thought we knew. In 1950, Jan Oort wasn't looking for monsters. He was looking for an explanation. Long-period comets, the ones that take thousands, sometimes millions of years to orbit the sun, were arriving from every direction. Not from a disk, not from a belt, from a sphere. All around us, which meant they had to be coming from a reservoir that encircled the entire solar system. He proposed a shell, a cloud, a vast spherical ocean of frozen remnants from the solar system's birth, stretching from roughly 2,000 astronomical units from the sun, that's 2,000 times the distance from Earth to the sun, all the way out to nearly 100,000 astronomical units. At that distance, the sun is just another star, dim, distant, barely a memory, and the objects out there, if they exist, are not orbiting in any hurry. A single trip around the sun could take longer than human civilization has existed. For 70 years, this was the model. The Oort Cloud was a static thing, a frozen archive. Occasionally, a passing star or a molecular cloud would nudge a comet inward, sending it on a suicidal dive toward the inner solar system. We would see it in our skies. We would name it. And then it would be gone. That was the deal. The cloud was passive, dormant, dead. But in 2003, we found something that broke the model. Sedna. Officially 90,377 Sedna. A dwarf planet roughly 2/3 the size of Pluto, discovered by Mike Brown, Chad Trujillo, and David Rabinowitz. Its orbit was wrong. Not just unusual, wrong. Sedna never comes closer than 76 astronomical units to the Sun. That's more than twice Neptune's distance. And it travels outward to nearly 1,000 astronomical units. But here's the problem. At that distance, it never gets close enough to Neptune, or Uranus, or any of the giant planets to have been thrown there by their gravity. So what put it there? The standard answer, the comfortable answer, was that a passing star millions of years ago disrupted the inner Oort cloud and scattered objects inward. But Sedna wasn't alone. In the years that followed, we found more. 2012 VP113, Liliaku Honua, several others. All of them in these bizarre detached orbits. All of them too far from the giant planets to have been pushed by them. All of them pointing in roughly the same direction. And that alignment suggested something that should have been impossible. Something was pulling them. Comets were supposed to be the messengers, not the message. For most of human history, they were warnings, harbingers. In 1680, the Great Comet blazed across the sky so brightly that it was visible in daylight. Edmund Halley, using Newton's new laws of motion, realized that the comets of 1531, 1607, and 1682 were the same object returning every 76 years. He predicted its return in 1758. He died before he could see it. But the comet came back. We named it after him. And we told ourselves we understood them. We were wrong about that too. In 2021, a team of astronomers led by Dr. Amir Siraj and Professor Avi Loeb at Harvard published a paper that should have gotten more attention than it did. They had run the numbers on long-period comets, the ones we assumed came from the Oort cloud, and found something disturbing. A significant fraction of them were moving too fast. Their trajectories, when traced back, didn't originate from the spherical shell we had mapped. They came from somewhere else, somewhere closer, somewhere interior to the classical Oort cloud. Siraj and Loeb proposed a controversial explanation that the Oort Cloud was not the only source of comets, that there was a second, denser population of icy bodies, a inner Oort Cloud, or detached disk, that we had been missing. But other researchers looked at the same data and reached a darker conclusion. What if the comets weren't coming from a place? What if they were being sent? Consider the timing. In the last century, we have seen an unusual number of bright, long-period comets. Hale-Bopp in 1997, McNaught in 2007, Neowise in 2020, Atlas in 2024, each one a spectacular billion-year-old ice ball falling into the inner solar system. Statistically, this shouldn't be happening so frequently. The Oort cloud is vast. The odds of multiple major comets arriving in a single human lifetime should be astronomical, unless something is stirring them up. In 1984, paleontologists David Raup and Jack Sepkoski published a paper that sent ripples through both biology and astronomy. They had found a pattern in the fossil record. Mass extinctions on Earth, the kind that wipe out 70, 80, 90% of all species, were happening on a cycle, roughly every 26 to 27 million years, like clockwork, like a heartbeat. They proposed a radical idea that the Sun had a companion, a small dim star orbiting so far away that we had never seen it, but close enough that every 26 million years its gravity disturbed the Oort cloud, sent a rain of comets inward, caused the impacts that reset life on Earth. They named it Nemesis, the Death Star. The Nemesis Hypothesis was largely abandoned by the 1990s. Surveys of the sky found no evidence of a companion star. But here's what nobody talks about. The extinction cycle remains. The data is still there. The fossil record still shows that pulse. Every 26 million years, something terrible happens. And if it's not a companion star, then what is it? What if Nemesis wasn't a star? What if it was something else entirely, something darker? Something we haven't been looking for, something that doesn't shine. Sometimes the most important discoveries happen when you're looking at something else entirely. In 2014, a team of planetary scientists led by Dr. Matthew Hedman was analyzing data from NASA's Cassini spacecraft, which had been orbiting Saturn for nearly a decade. They weren't hunting for planets. They were studying the rings. Specifically, they were looking at a strange, periodic wobble in Saturn's orbit, a disturbance that didn't match any known gravitational influence. Jupiter could explain some of it, the other planets a little more. But there was a residual, a leftover, a ghost in the math. They ran the numbers, and the numbers pointed outward, way outward, beyond Neptune, beyond Pluto, beyond the Kuiper Belt, to a region of space where, according to every model, there should be nothing large enough to matter. But the ghost gravity didn't care about our models. This wasn't the first time something like this had happened. In the 19th century, astronomers noticed that Uranus wasn't moving correctly. Its orbit deviated from Newton's predictions. They assumed there must be another planet pulling on it. They calculated where that planet should be. They pointed their telescopes, and they found Neptune. Gravity in that case had been a map, a guide. It had led them to discovery. But this time, the map is pointing somewhere different, somewhere darker. In 2016, Mike Brown and Konstantin Batygin at Caltech published what would become one of the most influential and controversial Taisheng papers in modern astronomy. They had studied 6 of the most distant known objects in our solar system. Sedna, 2012 VP113, and 4 others. Their orbits were aligned, not just roughly and precisely. They were all tilted in the same direction. They were all clustered in the same part of the sky. The odds of this happening by chance? About 0.007%. Batygin and Brown proposed the existence of Planet 9, a world 5 to 10 times the mass of Earth, orbiting somewhere between 400 and 800 astronomical units from the Sun. Invisible to our current telescopes, but massive enough to shepherd those distant objects into their strange, synchronized orbits. The astronomical community split. Some embraced Planet 9 as the most logical explanation, Others argued that observational bias, the fact that we can only see these objects when they're in certain parts of the sky, could create the illusion of clustering. The debate raged. It still rages. But here's the part that didn't make the headlines. Badigian and Brown's model didn't just explain the clustering, it made predictions. It said, if Planet 9 exists, there should be other objects in specific orbits. Objects tilted at exactly 90 degrees to the plane of the solar system. Objects with orbits so extreme they barely feel the sun's gravity at all. And then, one by one, those objects started showing up. But Planet 9, if it exists, is not the end of the mystery. It's the beginning. Because 800 astronomical units is far, but the Oort Cloud begins at 2,000 astronomical units. And if something is shepherding objects at 800 astronomical units, what is doing the same thing at 5,000 astronomical units, at 10,000 astronomical units, at 50,000? The ghost gravity doesn't stop at Planet 9. It keeps going. Deeper, darker, into the place where we swore nothing could live. Chapter 4. The Dark Object. In 2020, a paper was published in the Astrophysical Journal Letters that almost nobody outside of specialist circles noticed. It should have been front-page news. It should have changed everything. A team of researchers had been studying the orbits of long-period comets, not the ones with neat, predictable returns like Halley, but the true wanderers, the ones that come once, burn bright, and may never return. Comets with orbits that take hundreds of thousands, sometimes millions of years. Comets that touch the very edge of the sun's gravitational influence, and then fall back into the dark. They found that these comets were not random. Their aphelia, their farthest points from the sun, were clustered. Not scattered evenly around the Oort cloud as they should be, but concentrated in specific directions, as if something was capturing them, as if something was holding them. The authors proposed a disturbing possibility, that beyond the classical Oort cloud or embedded within it, there exists a massive object. Not a star, we would have seen a star, but something planetary. Something between the mass of Earth and Neptune. Something so cold, so old, that it emits almost no infrared radiation. Something that has been out there since the birth of the solar system. Or something that arrived later. Rogue planets are not science fiction. We have detected them, drifting between the stars, worlds without suns. Some formed in isolation, collapsing from gas clouds too small to become stars. Others were born in planetary systems and violently ejected by gravitational interactions with their siblings. The Milky Way may contain billions of them. And some of them, statistically, must pass through our solar system's backyard. In 2015, a team led by Dr. Haggai Peretz simulated what would happen if a rogue planet, roughly the mass of Neptune, passed through the Oort cloud. The results were catastrophic. Not for Earth, not immediately, but for the structure of the cloud itself. The rogue planet would capture thousands of comets. It would scatter tens of thousands more. It would create precisely the kind of clustering we see in the real data. But here's where it gets worse. A passing rogue planet would eventually leave. It would steal its captured comets and drift away into the galaxy. The disturbances would be temporary. A flash flood, not a permanent river, but the clustering we see is permanent, stable, ongoing. Which means whatever is causing it is still there. In 2022, another paper added fuel to the fire. Researchers studying the orbital dynamics of the outer solar system realized that Planet 9, if it exists, might not be alone. Their model suggested that a second, more distant object could be necessary to explain the full range of orbital weirdness, something in the 10 to 20 Earth mass range, something at 15,000 astronomical units or more. 15,000 astronomical units, that's a quarter of a light year. At that distance, the sun is just the brightest star in the sky, and an object that far away, that cold, that dark, would be nearly impossible to detect with current technology. But it would be massive enough to bend the orbits of anything nearby. massive enough to be a second shepherd, a second ghost. We have been looking for Planet 9 for nearly a decade.